In this video, we dive deep into how to implement multithreading effectively in a simple e-commerce application using Java 8 and above. Why multithreading in microservices? Microservices architecture naturally supports distributed and concurrent processing, as different services can run independently. However, within each microservice, multithreading can be beneficial for handling multiple requests concurrently. In high-traffic e-commerce applications, multithreading allows the system to handle multiple customer requests, e.g., viewing product details, checking out, or placing orders simultaneously, reducing latency by executing independent tasks in parallel, e.g., fetching product details, inventory status, and pricing from separate microservices. Overall response time is minimized. Efficient resource utilization. Multithreading ensures that CPU cores are effectively utilized, increasing application throughput. Asynchronous communication. It enables non-blocking operations, which is crucial for microservices that heavily depend on network calls or I/O operations. Key multithreading concepts in Java 8 and above. CompletableFuture. Introduced in Java 8, CompletableFuture is a flexible and powerful way to write asynchronous and non-blocking code. It allows chaining of tasks, combining multiple asynchronous calls, and handling exceptions gracefully. Ideal for executing independent tasks in parallel and then combining the results, such as fetching data from multiple microservices. Executor Framework. The Executor Framework, from java.util.concurrent, is a flexible and robust way to manage a pool of threads. It provides better resource management compared to manually creating threads by reusing threads from a pool. Types of executor services. Fixed thread pool. A pool with a fixed number of threads, suitable for controlling concurrency in CPU-bound tasks. Cached thread pool. A pool that creates new threads as needed but reuses previously constructed threads when available. Ideal for short-lived tasks. Scheduled thread pool. Used for scheduling tasks with a delay or at a fixed rate. ForkJoinPool. Designed for tasks that can be recursively split into smaller tasks and then combined, following the divide and conquer strategy. Works efficiently with the fork/join framework, making it suitable for parallel stream processing. It powers Java 8's parallel streams under the hood but can be explicitly used for more control. Springs at async annotation. Part of Spring Framework at async is an easy-to-use abstraction for asynchronous method execution. It allows the creation of asynchronous methods by simply annotating them with at async. Suitable for fire-and-forget tasks, such as sending notifications, updating analytics, or logging activities. Which approach to use? 1. CompletableFuture. Use case. When you need to perform multiple independent tasks concurrently and combine the results, e.g., fetching product details, inventory status, and pricing in an e-commerce app. Advantages: non-blocking and asynchronous. Supports complex workflows using then apply, then combine, all of, etc. Exception handling is built in using methods like exceptionally and handle. Challenges: more verbose and complex compared to at async for simple tasks. Requires explicit thread pool management for optimal performance. Executor Framework. Use case: when you need fine-grained control over thread management, such as setting the number of threads, priority, or scheduling tasks. Advantages: highly configurable with different types of thread pools. Better control over resource utilization. Challenges: more boilerplate code compared to CompletableFuture or at async. Requires careful configuration to avoid thread leaks or starvation. ForkJoinPool. Use case: ideal for tasks that can be split into smaller subtasks and executed in parallel, such as processing large datasets or implementing complex algorithms. Advantages: highly efficient for recursive tasks. Utilizes work-stealing algorithms for better CPU utilization. Challenges: more complex to implement and maintain. Not suitable for all types of concurrent tasks, particularly if tasks are not easily divisible. Springs at async annotation. Use case: when you need a quick and straightforward way to run tasks asynchronously, especially for fire-and-forget operations. Advantages: simple to implement with minimal boilerplate code. Integrated with Spring's dependency injection and transaction management. Challenges: less flexible for complex workflows compared to CompletableFuture. Requires proper configuration to avoid thread pool exhaustion. Choosing the right framework or concept. For asynchronous HTTP calls to other microservices, use CompletableFuture as it allows combining multiple non-blocking calls efficiently. For background tasks or fire-and-forget operations, use Spring's async for simplicity and integration with the Spring ecosystem. For CPU-intensive parallel computation, use ForkJoinPool as it is optimized for recursive parallelism. For fine-grained control over threading, use the Executor Framework, especially if you need to manage the number of threads or schedule tasks explicitly. Best practices for multithreading in microservices. Thread pool configuration. Avoid using the default common pool for heavy tasks as it can affect other parts of the application. Always use custom thread pools with optimal sizes based on CPU cores and the nature of tasks, CPU-bound versus IO-bound. Exception handling. In CompletableFuture, use .exceptionally or .handle to manage exceptions without blocking threads. In async, use async uncaught exception handler to handle uncaught exceptions. Resource management. Properly shut down thread pools to prevent memory leaks using shutdown or shutdown now methods. Monitoring and debugging. Use tools like Spring Actuator, Prometheus, or custom logging to monitor thread usage and performance metrics. Enable debug logs for better traceability in asynchronous workflows. Avoiding deadlocks and race conditions. Minimize shared state and use thread-safe data structures like concurrent hashmap. Always avoid synchronized blocks in asynchronous code as it defeats the purpose of non-blocking execution. Conclusion. Use CompletableFuture for complex asynchronous workflows, especially when calling multiple microservices in parallel. Use async for straightforward fire-and-forget tasks. Use ForkJoinPool for data processing tasks that can be broken down into smaller subtasks. Use Executor Framework for granular control over thread management and scheduling. Don't forget to like, subscribe, and hit the bell icon for more in-depth tutorials on Java, Spring Boot, microservices, and cloud-native development.